In this video I'm going to show you how to make a very simple runtime meter which will monitor a piece of equipment and record its running time in seconds, minutes and hours. In our schematic manager for our program, I am just going to go and open this FC1 which I have created, and in here I am going to start off with utilizing our 1 second pulse. I have created a previous video of how to get this 1 second pulse, which is a feature which is inside your CPU. If you're not sure how to set it up, there's a link in the description below to the video which shows you how to set up the pulse or clock memory function of your CPU. So this triggers every second, and we can utilize that to count the seconds of which the machine is running. Next we will need an input which will state that the machine is running. Now this could be a memory bit. For this example I'm just going to use input 0.0. Next we need to use an add function. So we're going to insert this add integer block, and we are going to add a value of 1 into a memory word. I'm just going to choose memory word 20, and the output will be memory word 20. Now the idea of this, if the machine is running and the input is on, every 1 second this will have an enable signal which will add 1 into memory word 20, which equals memory word 20. So if memory word 20 is 0, then every time this pulses it adds 1 to the 0 to equal 1. Next pulse adds 1 to the 1 to equal 2, and so on. Now the only issue we have with this is every time the PLC does a scan, it will redo this addition for as long as this is on. So if it does 10 scans in a second, it will add 10 to the memory word in that 1 second. So we need to insert a positive trigger. Just like so. And this needs an address, so we'll just call this M10 for now. M10 bit 0. And now this will only enable this to be active on the 1 cycle that this becomes positive. So it will happen once every second rather than once every scan within that second. So this is going to count our seconds, so let's call it seconds. Seconds. And new network. Now we're going to do a comparison of equal. So when this memory word gets to 20, we want it to create a minute. So what we're going to do is we're going to compare to the value of 60 seconds the value of memory word 20. If memory word 20 equals 60, then we get this output, and then we can use that in a similar way to add our minutes. So we'll get another addition, add integer, and now we want to add 1 into a new memory word, which we will use memory word 22. Memory word 22. So in a similar fashion, when this counts to 60, we get 1 out, and that adds 1 onto the minute which we are using as memory word 22. Now again, we need to use a positive trigger. Um, 10.1. And for the next network, let's just call this minute. So you could probably guess that this one is going to be an hour, and this one is going to be pretty much exactly the same. So comparator for equal to, and we're going to compare if memory word 22, which is our minutes, is equal to 60. If it is, we have a positive edge of M10.2, and again we will add a value of 1 into memory word 24, which will be our hours. And we have now, whenever the input is on, we will be able to count our seconds, and we'll be able to count our minutes, and we'll be able to count our hours that this input has remained on. Now when the minutes get to 60, we need it to reset, so I'm just going to put a new network in. So to reset our minutes back to 0 after it's reached 60, we need to use a move function. And we're going to move the value of 0 into our memory word for our seconds, which is memory word 20. And the point at which this is going to happen is when we get the output from the comparator to say that memory word 20 has equaled 60, and the output is M10 bit 1. So M10 bit 1. So just to recap, when memory word 20 is equal to 60, which is 1 minute, we get the output, which then moves a value of 0 into memory word 20. So it'll get no higher than 60, back to 0, it'll count to 60, back to 0, count to 60, back to 0. So we will call this reset seconds to 0 after 60. and we need another one to reset our minute back to 0 after 60. Reset minutes to 0 after 60. Exactly the same way, we need a move function. We'll move 0 into our memory word for minutes, which we used as memory word 22. And to enable this, we need to use M10.2, which is active after the minute equals 60. M10.2. And now, when we run this program, as long as that input is in, the seconds will go from 0 to 60, which adds a minute. The minutes will go from 0 to 60, which adds an hour. And it will count for as long as that input is held, and we can monitor memory word 24 for hours, memory word 22 for minutes, and memory word 20 for seconds. And then we can utilize them in some sort of display, or just monitor them in a VAT table, and we will know the running hours of, say, a pump if it's used for that. Now, if we do some service and we want to reset the running hours back to 0, or we install a new pump, then we need a function to reset the counters all back to 0. So we will insert a new line. We will have a reset input, so let's use input 0.1, and for this we're going to utilize 3 move functions. And we're going to insert 0 into each one, and a 0 into our seconds, which is memory word 20, and now a 0 into our minutes, which is memory word 22, and a 0 into our hours, which is memory word 24. So I'm just going to go ahead and save this, and I'm going to download this to the PLC simulator. And what I'm going to do before we monitor it is create a VAT table. Just open it up. Here we go. So now I'm going to just monitor our inputs. 0.0, which is our run. Input 0.1, which is our reset. And then memory word 20, which is our seconds. Memory word 22, which is our minutes. And memory word 24, which is our hours. And we want to view these as decimal, so that they're realistic numbers. We'll save that, and we will monitor this, and we can see at the moment input is off, running is off, reset is off, and our seconds is 0, our minutes is 0, and our hour is 0. So if I just go to the PLC simulator and trigger the 0.0 input, which you see has become true, we'll go to our ladder and monitor this. And it's not being processed. And so if we monitor our VAT table, we can see input 0 is false, which is our running enable. Input 1 is false, which is our reset. And so if we look at our VAT table, currently the machine is not running, so input 0.0 is false. Our reset is false also, which is input 0.1. And so our seconds, our minutes and our hours are still reading 0. So if we now activate our input 0.0 to show that the pump or whatever we are monitoring is running, you can see the input becomes active and you can see the seconds, they start to count. I'm just going to pause this while it counts up to a minute and come back when it gets to just before a minute. So I've resumed the recording just as we're getting up to a minute, and you can see that the seconds reverted back to 0 and we have our first count of a minute. Now I'm going to leave this running for the next couple of hours, and I'm going to come back just before the hour mark and resume the recording so you can see the transition from minutes until hours. So I've resumed the recording at 59 minutes 55 seconds so far, and you'll see the transition to the first hour. The minutes reverted back to 0 after 60, the seconds reverted back to 0, and so we can see that now our machine has been running for 1 hour and 14 seconds. It's a really simple way of creating a runtime meter to monitor running times of a machine or a pump or any particular item of equipment. This makes it easy to flag up for maintenance reasons. Say after so many running hours you can have an alarm alert on the machine to say maintenance is needed. Real simple to implement, and doesn't take long to do at all. Well, I hope you found that useful. Come and see us over at learningautomation.net and find more useful hints, tips and projects to follow.